Hello, Data Science for All. We're Team 27 and we're very happy to present to you our project, Real-Time Monitoring and Forecasting of Encicla Bike Sharing Network using Machine Learning. My name is Hugo and I'll be your host tonight. First things first, our team. We have Brandon, he's a data science master student and a senior professional in supply chain. Second, we have Claudia. She's a full-time professor at EAFIT University. Then we have Javier. He's country manager at PS Colombia, a Spanish industrial technology company. Jorge is the lead of data and AI initiatives at Avista. Next is Kevin, who's an engineering science master student at Telecom Paris. And finally me, Hugo. I work as an engineering manager for Rockwell Automation. All right, let's get started. So a little background. Encicla is our city's public bike sharing system. So you basically go to a station, pick a bike, ride it to the station that's closest to where you're going, and then leave it there. Encicla is part of the integrated transport system of the metropolitan area and is mostly used for last mile trips. Of course, Encicla's demand fluctuates a lot. Some stations have a very high demand, while others have very little demand. In those stations with high demand, it's very often for users not to find an available bicycle. And it's also very common for them to not find a dock if they want to leave their bike in a station that's not regularly used. So stations are full, they don't have a place to leave their bikes. This is actually a very common problem in similar systems around the world. This is mostly because of something known as the last mile problem. There are only so many docks. And according to some studies, if there is no dock in about a mile of where the person wants to start or end their trip, they're simply not going to use the system. And of course, they're going to complain about it. Because this is a fairly common problem, people have tried to solve this issue, of course. China, for instance, started using what they call a dockless model, which you might have seen. It's a model in which you unlock your bike with your phone with an app, then use your bike and leave it wherever you want. And I mean wherever you want. So you guys know that sometimes the cure can be worse than the disease. This model in China led to having piles and piles of bikes in places where nobody needed them, while leaving other parts of the cities uncovered. Our Encicla system hasn't yet adopted this dockless approach, luckily, but still suffers from the last mile issue, as we'll show in a few minutes. All right, business impact. In this context, having a demand prediction model for Encicla could help the system solve its effectiveness issues and minimize that last mile problem. There are three models that we have proposed. First, by using forecast machine learning modeling, we want to try to optimize the number of bikes that need to be available in each station at any given time of the day. Second, a forecast model that can eventually trigger an alarm that indicates if a station is going to run out of bikes, so they can more efficiently dispatch and provision the trucks that pick up and load the bicycles in each station. And third, we want to have an improved user experience by having a map that lets them visualize the current state of each station, but that also shows the availability prediction for the next 10 minutes, as well as a weather forecast based on a public weather API, so users can make better decisions on which stations to use and when. So we're trying to make their lives better. All right, let's see some data science in action. So first, of course, we did some exploratory analysis that actually led to finding some irregularities in how the bicycles were distributed across the system. Some stations had always 0 bikes, for instance, while some stations had numbers that never changed, meaning that no one ever used them. Some stations would start with X number of bikes and then quickly reached low numbers and then were never resupplied, and so on. We found many things. In chart number 1, for instance, we're looking at the standard deviation distribution of bikes in stations. It is very noticeable from this chart that most bikes are concentrated in a low standard deviation, which means that most stations have a low demand. Chart number 2 shows a histogram of the number of times that stations ran out of bikes. As you can see, many stations never run out of bikes, while few others, although very frequently, would run out of bikes all the time. This shows that, in fact, bike provisioning is not well distributed among all the stations. And finally, in chart number 3, we're showing a simple sample station. According to this chart, it seems like the number of bikes over time follows a very specific pattern. That pattern is precisely what we want to be able to predict with our project. All right, so we created 3 models. First, we created a linear model to try to predict the number of bikes at a specific time with the data from other stations at that time minus 10, right? So we wanted to predict what the station would look like at 8 o'clock from data from other stations at 7:50. Second, we used an LSTM neural model to predict the number of bikes at a specific time, but this time using variables like the number of bikes from 10 minutes ago and time periods like the month, the day, or even hours. We actually even use some different date types, weekdays, working days, holidays, to try to make the prediction more accurate. Finally, we also created another LSTM model to try to predict bicycle availability for a station within the next hour. Because this was a more complex model, this was a binary prediction, so we would get an either true or false. Based on all this, we defined that the best model to use was LSTM because it presented a considerable decrease in the defined metric, which was MSE in our case. All right, so what did we conclude from all this? The first major conclusion of this study is that we can, in fact, predict the demand of a specific station with an acceptable precision using the currently available data. This tells us that the model was capable of generalizing or adapting accurately to new and never before seen data obtained from the same distribution of data that we used to create the model in the first place. Second, we firmly believe that the 1-hour model that we developed can be a fundamental input for the system in terms of how they perform planning and operation in Encycla. It would allow for better decision making and of course it will enable a more productive system overall with happier customers. And finally, this study can be a great input for performing vehicle routing problem modeling, also known as VRP, which would optimize even further bike provision for Encycla, leading to a much more efficient public service. All right, let's go to the site. So what you see here is an ASP.NET Core website that's hosted in Azure that connects to a Postgres database hosted in AWS, which is populated by our Python scripts that run as an automated process. Homepage shows some basic info about the project, but we have 2 main pages. The station map will show a real-time map with the status of each station, the availability of station bikes based on the capacity. So this is the number of currently available bikes, and then this is the prediction that we did with our machine learning models for what we predict would be the availability within the next 10 minutes. If you click on this show predicted stations checkbox, you'll see the 1-hour prediction that I talked about. These are, in this case, in real time, the 2 stations that we predict that will run out of bikes within the next hour. If you go to the station details page, you'll be able to select the station to see the specific details for that station. What you get to see here is some basic data about the station, a picture, the zone where it's located, the same availability and prediction, the weather information, and then you can see in blue the actual availability of that station throughout the day, and in orange the prediction that we made. As you guys can see, it seems pretty accurate. This heat map shows the availability of each station based on the week, day, and the hour. All right, guys, hope you enjoyed it. Thank you. This was Team 27 Have a good day.